Right.
Hi everyone. Now I am here to explain the PowerPoint presentation of the project Microwave Oven for the completion of embedded system internship from Emertxe Technologies. Let me introduce myself. This is P. Kushwant from Rajiv Gandhi University of Knowledge and Technologies, Ongole. We are a group of three members consisting of B. Nikhil, P. Kushwant and M. Yogeshwar. Now I am going to start the PowerPoint presentation explanation. Let me conclude what we learned during the internship. We learned about the C language, conditional loops and operators in the C language, arrays and pointers, functions and strings, storage classes, embedded system and microcontroller, like basics about the embedded system, introduction to the embedded system, and microwave oven project. To simulate the microwave oven project, we used MP Lab, XCB, PICSIM Lab softwares, and we learned about the various peripherals of the PIC16F877A, and we also learned interfacing of various peripherals to PIC16F877A, and we also participated in various quizzes during this internship. This PowerPoint presentation includes introduction to the embedded system, components of an embedded system, embedded programming, and about the project, that is microwave oven project, and the simulation of the project. Demo video is also included in this video part. Firstly, I will introduce what is an embedded system. An embedded system is a small computer designed to perform a specific task within a larger device. Like we can see many applications of embedded system in our daily life, like a simple washing machine or a projector. Everything will come under the embedded system domain. Industrial robots, GPS receivers, digital camera, MP3 player, all these are the examples for the embedded system. Embedded system mainly consists of a microcontroller or a microprocessor, software and hardware components working together to control functions like sensing, processing and output. We can simply define an embedded system like it's a combination of both software and hardware, and as well as firmware also. As I already included, examples for the embedded system are washing machines, traffic light system and smartphones. Let me give examples. Let me give about the components of embedded system. Mainly we can consider these input output ports, memory, other devices and system core are the components of the embedded system. Input is nothing but sensors and output is nothing but actuators for an embedded system. Memory is where the program or the code is stored for an embedded system. Other devices are known as peripherals here. System core is the main for the embedded system, like microcontroller or microprocessor, FPGA. All these are the examples for the system core of an embedded system. So input ports, output ports, memory, system core are the components of the embedded system. System core. System core of an embedded system includes microprocessor, microcontrollers, FPGA, where FPGA is known as Field Programmable Gate Array. 8085, 8086 are few examples for the microprocessor, where 8085 and 8086 are the Intel company microprocessors. ARM Advanced RISC Machine DSP Digital Signal Processor. 8051 PIC Peripheral Interfacing Controller are the few examples for the microcontrollers. Embedded programming. Embedded programming refers to writing software that runs on embedded system, which are specialized computing devices designed to perform specific tasks. As I already included earlier, embedded system is a combination of both software and hardware. Hardware performs on the basis of the software code which is included in it. The software code, we can write the software code by using C programming or C++, assembly programming, Python, Java also. These are the most popular languages for the embedded system. We can also have the embedded C for writing the code for an embedded system. So embedded programming involves low-level programming to control hardware components like microcontrollers, sensors and actuators. Sensors are the inputs for the embedded system, actuators are the output for the embedded system. Microcontroller is used to work with these inputs and outputs, which are sensors and actuators. These are known as the hardware components for the embedded system. So now we will see the differences between the C programming language and embedded C. C is a general purpose language used for developing software, while embedded C is specifically designed for controlling hardware in embedded system. C runs on computers with operating systems like Windows, Mac or Linux. Whereas embedded system runs directly on hardware, which is microcontrollers of the embedded system without an operating system. To run the embedded system, we don't need any specific operating system. These are performed or run in the microcontrollers itself. C programs have more memory and processing power available, whereas embedded C must be optimized for small memory and low power usage, as embedded devices have limited resources. Next slide is Introduction to Embedded C. This will be continued by my fellow teammate Yogeshwar.
Hello everyone, I am Yogeshwar. As my fellow member Kushwant has explained some of the PPT slides, now I am going to explain it from now on. Introduction to Embedded C. Embedded C is a programming language specifically used to develop software for embedded system, which are small computing devices designed to perform dedicated functions. It is an extension of the C programming language, but with additional features that allows the direct interaction with hardware components like microcontrollers, sensors and actuators. As we all know that the sensors take the input and the actuators does the work, and these all are controlled by a microcontroller. And coming to the key features in embedded C, uses standard C syntax, as the syntax of in embedded C and C are same, with including loops, functions and conditions, etc. Direct hardware access, uses registers and ports to control the hardware components. In this embedded C, there are no standard libraries are used, such as we used in C like printf, scanf. In this embedded C, we usually used the CLCD and matrix keyboard. Like these functions we used in very frequent. Efficient memory management, optimized for minimal RAM and ROM usage. Real-time processing, enhances immediate execution of tasks critical for embedded applications. As we know that the real-time applications where the embedded is mainly focused in. And coming to the data types and variables, embedded C uses a standard C data types, but they are optimized for the embedded system with limited memory and processing power. It also includes hardware specific data types that interact immediately with the microcontrollers, registers and memory locations. Now coming to data types, for basic data types and derived data types, and variables are local variables and global variables. As we know that the global variables are included outside the functional block, and the local variables are included inside the functional block. And coming to the basic data types, the int, char, float and double, etc. And derived data types are array, pointers, structures and union, etc. And coming to the about this project, as we included it our in thumbnail that it is in a microwave oven, let's dive into the most deeper parts of this project. In this project, we are going to simulate the micro oven, which is known as popular application of embedded system using PIC Lab. What is a microwave oven? A microwave oven is an electrical kitchen application that uses microwave radiation to heat food. It works by an emitting electromagnetic wave that causes the water, fat, and other molecules in the food to vibrate, producing heat and cooking the food from the inside and out. And coming to the architecture of PIC Lab, as we see that this architecture of PIC 16F877A, as we seen here, where the bilateral and unilateral signals has been given here. And let's dive in more deeper into it. Coming to the right side of this architecture, RS232 is a bilateral which gives the signal into the PIC and takes the signal out of the PIC, and LEDs are the unilateral which only display the signal that from the PIC, and buzzer which gives an input to the PIC simulator, and a digital keyboard as an unilateral which it takes gives the input to the PIC, and SSDs will transport the output outside the PIC, and a matrix keyboard which is a bilateral element which takes the input from the outside element and gives output to it, and GIPO which is also an bilateral element which takes the input from the PIC and gives output from its sensors, and the others has been mentioned here, and LM35 temperature sensor which takes the reading from the outside the environment, and IC2 RTC, and EEROM which is which store the memory in it. And coming to the PIC microcontroller, for the PIC microwave oven project simulator, we use the PIC microcontroller. We have various versions of PIC microcontroller. Among all of them, we use PIC 16F877A. It is an 8-bit general purpose microcontroller, where in this microcontroller we use a RISC and flash memory are the key features of this PIC microcontroller. And the peripherals of the microcontroller that we use in this simulation are CLCD, which is abbreviated as a character liquid crystal display, which is used to display the screen that we used of various operations. This is a simple display screen used in the embedded system to show the text and the numbers and symbols. How does it work? The common question that we all arise in the mind of us, and it receives the data from the microcontroller and process these into its understandable language and display the data in its screen. And matrix keyboard, as I mentioned earlier that these were used. A matrix keyboard is a type of a keypad with multiple buttons arranged in rows and columns to reduce the number of required input pins. It is commonly used in the embedded systems as calculator, ATMs, security systems, and industrial controls. And the process of this microwave oven is followed by 4 steps, which was explained by my fellow member Nikhil with its code and how the simulation works, and it is over to Nikhil.
Hello everyone, I am B. Nikhil from RGKT. Now, as my fellow team member said, I am going to explain the output of microwave oven, our embedded systems project by Emertxe. So we are using MPLabX IDE for this project. So let me show you the output and code. So let me show you the code. So as you can see, we are here is the main file. So I named it after instead of naming it a main, I named it with another name. So let us dive into the code. As you can see, uh, we considered watchdog timer off, and now we assigned the value key value 1 for the microwave mode, and key value 2 to the grill mode, and key value 3 to the convection mode, and key value 4 for the start mode in microwave oven. And as you can see, we have set various acceptance and entry keys and various back keys in the microwave oven. And for the time display, we are using minutes and seconds to display the time. We have set minimum time and maximum time, as you can see here. So when we are opening the microwave oven, when we access any mode in microwave oven, we can see that it asks for a time to set the time for the working of microcontroller, for the working of microwave oven. So we can set the time in minutes and seconds. And now coming to this module, we can see that with the when the time is up, or when the function is completed by the microwave oven, the buzzer will be on, and the screen will be cleared, and making it into the front screen. And and also, instead of dumping everything in a single code, we are developing different different files for various functions like CGLC, timers, LEDs, etc. So, and developing all these files in a different formats, and we are including every file in the main file. As you can see, this is the main code. So let us jump into the execution of the project. So I am using PIC lab for the execution. So as you can see, I am opening the app image of PIC lab. Now I am going to open my microcontroller that I am using for this project. So let me select my microcontroller. I am using PIC16 F877A microcontroller. It's 8-bit microcontroller. And let me select a 16x4 display CLCD. Now, and let me dump the code. So here I am loading the code, a hex file, into the PIC lab. So as you can see, it is turning on. I am setting the clock frequency at 20 megahertz. So as you can see, it's better for the display. So let us verify the output of microwave oven. As you can see, the microwave oven is open, and now you can see there are 4 modes displayed on the CLCD. So the first mode is microwave mode, second mode is grill mode, third one is convection mode, and fourth one is start mode. The micro mode is used for a regular purpose, and the grill mode is used for cooking of the meat and bread. Convection mode, whereas the convection mode is used for preheating the oven by setting a particular timer for a particular time. We can preheat the oven by using the convection mode. So let us start with it. So let me verify the microwave mode first. So for selecting the microwave mode, let us click on matrix keyboard 1. So as you can see, the power required for the microwave is 900 watts. Now let us set the timer for 5 seconds, and let me start the operation. As you can see, when I press the enter, the timer runs and the oven starts working. As you can see, and when the time up, it stops. Now let us verify the grill mode. Now at the same time, as you can see, we are having the display format of time, minutes and seconds. Now let me set the time for 5 seconds, and now let me start the grill mode. As you can see, the fan rotates as it indicates the microwave oven is working. And you can see there are 2 other options, pause and resume. As we are setting up the microwave into a particular mode, you can see this is the convection mode and preheat, and the oven is going under preheating. It's taking 11 seconds, 10, 9, and so on. So when the preheating starts and the other functions of the microwave are going to the starts, we are using XME compiler and MPLab IDE for executing this prototype or the simulation of this microwave oven. Now let me show you the convection mode. So let me start. Okay. So as my friends explained, this Emertxe has helped us to develop our own prototype or a simulation model of microwave oven. So we are thankful for that. We have learned a lot from this internship. So I thank Emertxe on behalf of my friends and behalf of my team. So thank you for giving this opportunity to share our project. Thank you.